So in our previous class, we started discussing about differences between static routing and dynamic routing, and introduction to dynamic routing and dynamic routing types, dynamic routing advantages, classful and classless routing protocols, and we done RIP, routing information protocol. RIP is open standard. It's a distance vector protocol. The classless routing protocol, which is RIP version 2. And metric of RIP, RIP will choose the best path based upon the hop count, and maximum hop count is 15. 16th is unreachable. The good thing is it will do load balancing when hop count is equal. So RIP uses multicast messages using 224009, and RIP will send periodical updates for every 30 seconds. Even if neighbor is down also, it will still sending update actually. This is R1 router connected to R2. R2 network is standard network. What R1 is doing is R1 will maintain standard network update by RIP protocol. So R1, R2 will exchange updates for every 30 seconds. A complete routing table, which we call update timer. Point is what after some time router 2 is failed. If router 2 is down, still is there any requirement R1 to send updates to R2? Actually no need. Even if neighbor down also, what R1 will do is it will still sending update packet for every 30 seconds up to 180 seconds. So till 180 seconds, if it's not receiving any update from R2, then R1 can consider, okay, it is R2 is down because it's been 180 seconds. Basically, I'll get every 30 seconds update, but it's been 180 seconds, no updates from R2, it might be down. Okay. After 180 seconds, R1 come to know R2 is down, but then why we need to maintain 10-dot network information in routing table? No need to maintain. If you maintain the 10-dot network, it means it is a false information now. But what R1 doing is, it will still maintain the 10-dot network information up to 240 seconds. Up to 240 seconds, if there is no update from R2, after 240 seconds, this 10-dot network is flushed from routing table. So 30 seconds are update timers. 180 seconds we call invalid timer. And 240 seconds are flush timer. So finally, what I'm trying to explain here, RIP protocol conversation is very slow. 30 seconds, 180 seconds, 240 seconds. And what are the major drawbacks in RIP? More bandwidth is utilized for sending periodical updates. Does not consider in bandwidth in metric calculation, uses only hop count. Remember? So it will check only hop count actually. Slow conversions, a limited hop count is 15. These are drawbacks of RIP. Today I'll continue with next protocol is link state routing protocol. In link state protocol, thing is every router maintains full picture of the topology. So it's a very important point. Remember, every router maintains full picture of the topology. This is the topology. A router A should maintain B networks information, C networks information, D networks information, E, F, G, H. Full picture of the topology A should maintain. Similarly, B also should maintain rest of remaining all routers networks. Like H router also, E router also. That is the point. Every router maintains full picture of the topology. Link state protocol is more scalable. It's not like RIP protocol. RIP protocol supports maximum 15. 16th is unreachable. In case of link state protocol, more scalable. This protocol is compatible for small networks, medium networks, large networks, very large enterprises. So there is no limit in hop count. It supports unlimited hop count. It's a very good advantage in link state protocol. Even if any change in topology is quickly updated. In case of RIP protocol, if any change, after 30 seconds, you'll get a notification, right? You'll get an update message. So-and-so link is down. After 30 seconds, you'll get it. But in case of link state protocol, any change in the topology is quickly immediately, quickly update. It's a good thing. So compared to linked distance vector protocol, linked state protocol has more advantages. Let us see. Linked state protocol is OSPF, stands for opens shortest path first. Open shortest path first. The OSPF. OSPF is a linked state protocol, is also open standard protocol. Actually. The algorithm name is Dijkstra algorithm, or we can call SPF algorithm, shortest path first algorithm. It's also classless routing protocol. The thing is how it will find the best path. How it does find the best path. Okay. RIP will find the best path based upon hop count. But how OSP will find the best path? So what is the metric of RIP? RIP metric is hop count only. But what about OSPF metric? OSPF metric is cost, nothing but a bandwidth. So based upon the bandwidth, OSP will find the best path. Like which link is a bandwidth, high bandwidth, that is the best path. So it does not check any other parameters. It will look into bandwidth. Like it is 10 Mbps link. If it is 80 Mbps link. It is 20 Mbps link. In this topology, if we configured RIP will say 0/0 is the best because of hop count. But in this topology, if we configured OSPF will say my best route is 0/1 because it's high bandwidth, 80 Mbps. So that bandwidth is calculated by one formula. We call it is cost. So cost calculated with 10 power 8 by bandwidth in bits per second actually, BPS. Example 10 power 8. I'll explain clearly about this formula later, just to understand. Cost is 10 power 8 by bandwidth. It's 10 Mbps. If you do calculations, we'll get some max value. So this value we call what? Cost. So based upon cost, OSP will find the best path. Ultimately, cost is nothing but what? Bandwidth only actually. Yes, metric of OSP is cost. 10 power 8 by bandwidth in bits per second is only for Cisco. Like RIP will send the multicast messages using 224009 OSPF 224005. Like what if you have it is 80 Mbps, it is also 80 Mbps, is also 80 Mbps, then which is the best path?
ABH
Why ABH?
is the shortest path.
No, we
Multicast?
configured is OSPF, right?
Our best path.
All are best path. Bandwidth is same, 80 Mbps, 80 Mbps, 80 Mbps. So even OSPF also support for load balancing when there is a equal cost. Now bandwidth is same for all interfaces. So load balancing actually. OSPF protocol supports equal cost load balancing for 4 paths. Remember AD value for static routing, administrative distance for static routing,
1.
1. For RIP, RIP is 120, OSPF is 110. Okay. Yeah. So next thing is, how exactly OSPF work is. This is a database for a router. There are some 1 dot network, 2 dot network, 3 dot network, 4 dot network. This is database with router A. There are routing information here. If we configured RIP version 2, you know how RIP version 2 works? This complete routing information, you just configured RIP version 2, that's all. Then A router blindly, it will send update to B, it will send update to C, it will send update to D because of B, C, D are neighbors. Even neighbor is fail also, it's still sending update. That is the main reason RIP consume more bandwidth actually. It's not like much intelligence protocol. It is not checking whether neighbor is active or not. It's just sending update up to 180 seconds. If still it is not receiving update, then it will stop sending update actually. Bandwidth is consumed. But OSPF is not like that. OSPF is very intelligence protocol. What OSPF will do if you configure OSPF, directly it will not send update packet. I mean database to neighbors. What OSPF will do? First it will check neighbor. It will discover the neighbor. Router A will discover neighbor. Like who are my active neighbors? B, you are my active neighbor. C, you are my active neighbor. D, you are my active neighbor. Like who is my neighbors? To discover, OSPF will use one mechanism called hello packet mechanism. So first initially it will send a simple hello packets, not a database. After successfully establishing the neighbor relation, then database will exchange. Otherwise it will not exchange the database action. So what first OSP will do? It will discover neighbor. To discover the neighbor, OSP will use one mechanism called what? Hello packet mechanism. And this hello packets is keep alive mechanism for every 10 seconds to maintain that neighbor relation. Okay. So for every 10 seconds, it will not exchange the database. Only a simple small hello packet will exchange to maintain the neighbor. It will not use much bandwidth like RIP protocol actually. So A router will send hello packet to one of the neighbor directly connected is hello B, hello packet to C, hello packet to D. If BCD router is also configured with OSPF and they are active, then B will give reply hello A, hello A, hello A. Then A will understand, A will maintain, oh, router B is my neighbor because I got a reply. Router C is my neighbor. Router D is my neighbor. So to discover neighbor and to establish a neighbor relation, that neighbor relation to maintain, to continuously maintain, OSPF will use hello packet mechanism for every 10 seconds. After some time, if B is got failed, you know what A will do? Hello B, 10 seconds. No respond. Hello B, hello B, hello B. 4 consecutive hellos means 40 seconds. If it is not responding, I mean, if it is not receiving hello, then A will tell B router, you are no more my neighbor. You might be dead because have waited for 4 hellos. You didn't give reply. You might be dead. You remove the routing table. B is no more in my tables. It will remove the information within how many seconds?
40 seconds.
40 seconds. What about RIP protocol? 240 seconds. And OSPF is just 40 seconds. So hello timers are 10 seconds. Dead interval timer. Dead timer is 40 seconds. Neighbor is discovered and established by hello packets. Hello packets 10 second. Dead interval is 40 second. And good thing in OSPF protocol supports unlimited hop count. I'll give 2 points about RIP and OSPF. Point number 1. What is update in RIP protocol? Point number 2. What type of updates in RIP? What type of updates in RIP protocol? What is update in OSPF? What type of updates in OSPF? Anyone can answer for RIP protocol? What is update in RIP? Complete RT means complete routing table is update. In routing table, if there are 10 networks, complete 10 networks need to be sent as update. 20 networks, 30 networks, 300 networks. So for every 30 seconds, complete routing table is sending as update in RIP protocol. That is the main reason RIP consume more bandwidth actually. Got it? Then what type of updates? When RIP will do update? When RIP will generate the update packet?
Every 30 seconds.
Every 30 seconds. What we call the type of updates?
Updates.
Periodically updates. We call periodic updates. For every 30 seconds. So this is the main reason RIP protocol will use more bandwidth. Now let us check in OSPF protocol. In OSPF, what type of updates in OSPF protocol? So OSPF only first time hellos exchange. Router A will send hello, B will send hello. Then A and B will become what? Neighbor relation. So once neighbor is established, then A will send database to B. Only one time. That's all. B will send database to C. A will send database to D. Only one time. That's all. So once all routers are maintaining up to date routing information, every routers are up to date, updated with same all the information, then no more changes, then no updates actually. It's not like periodical updates. Initially only database exchanged. Once all routers are maintaining up to date routing information, then no updates. Then when next update, if any change happen in the topology, like so and so on serial interface 0/0 is down, then B has to be updated to A will update to all routers. There is a change in our topology. Every router to please maintain this information. And there is a link is up, again update action. If any network is added or any network is down, so when there is a change in topology, then only update. If no changes in topology, no updates. So these type of updates we call incremental updates. Incremental update means when there is a change in topology, then only update. If no changes, no updates actually. Got it? Case of RIP, what type of updates?
Routing table.
In RIP, what type of updates? It's periodical.
Periodically 30 seconds.
Every 30 seconds, complete routing table is sending is update. Yeah. Okay. Then what is update in OSPF protocol? What is update in RIP? It's complete routing table. In routing table, you have 4 networks. 4 networks will send as update for every 30 seconds. In routing table, there are 40 networks. Then complete 40 networks will send as update for every 30 seconds. But OSPF is not like that. What OSPF will do? Serial 0/0 is down. Then update is only about serial 0/0, not complete database. Serial 0/0, we call it is L, means it's a link. Serial 0/0 is a link. What happened to serial 0/0? Down. So yes, means the state of that link. What is the link state? It is a down action. This information, serial 0/0 is a down. This information is going to be advertised. So we call it as LSA. So what is update in OSPF is LSAs, link state advertised. It's not like complete routing table. Which link is being changed happened, means it is down or up. Which link is been missing, that information only will be updated actually, not complete routing table. So now compared to RIP and OSPF, then which protocol is utilized more bandwidth and which protocol will consume more bandwidth, less bandwidth?
RIP uses more and OSPF uses less.
Yes, because of like there are major advantages, like more advantages in OSPF protocol. So OSPF protocol, quick updates. Any change in happen is quickly updating. And it supports for unlimited hop count. And it has neighbor discovery mechanism and faster conversation. Within 40 seconds, neighbor is dead. And it supports for incremental updates. And it moreover, it considers the bandwidth to find the best path. Best path selection based upon the bandwidth. Incremental updates. And not complete routing table is update, only missing route, only the change that happen, only it will be sent update actually. So which routing protocol has more advantages, RIP or OSPF?
OSPF.
OSPF. It supports unlimited hop count. It is recommended for larger enterprise networks. So in real time, almost all large companies, corporate networks are using OSPF and service providers are using OSPF only. OSPF sends updates, means LSAs, when there is a change to one of its links, then only it will send updates. Otherwise, no changes, no updates. We call it is incremental updates. Yeah. Protocol number 89. Clear? Any doubts?
If there is any change in the router, like we add one more couple of routes, so the link will not go down, right? So how does that?
Even if we added new networks, there is a change happen.
So will it be considered as that?
Yeah, it will be considered as a change. So there is no link down here. This is existing topology. Everything is up and running. There is no changes. Then no updates. Now you just added some new networks, means new routers you have added. Router 1, router 2. So what router 1 will do, it will send hello packet to A. A will send hello packet to R1. R1A will establish a neighbor. R2N will establish a neighbor. So what A will do, oh, have two new neighbors. I'll update to my existing neighbors. So A will update to hello B. There are two neighbors are added to me. You also maintain that neighbors information. Update to C, update to D. And B will update, H will update. Then all neighbors also will be maintain this R1, R2 information.
I have a doubt. Hello.
Yes, please.
Yeah. What if I want a router to like, if suppose I take a router B and it should be secured, and the information updated in the B shouldn't get into other routers, then that should not be in the topology itself, right?
See, no, it is not possible actually, because the protocol behavior is to need to be update. It cannot be hide. It cannot be controlled. Whatever networks are available, it has to be send update to neighbor, because all routers should know that my information. But if you want to provide security only, then what we need to do? We need to implement it PBR, means policies we need to write. We call it is policy based routing. Normal routing will done updates for every routers actually. Means every routers will maintain the routing information. But what your requirement, router B networks or specific networks should not be advertised to other routers. It should be only in B router. Then you write a policy. So and so list of networks, it should not advertise to A and H. That's all. You just simply write, don't advertise to my neighbor. If you're not advertising neighbor, then neighbors will not advertise to any other routers. So the networks will be in B only. So that routing we call policy based routing. Like this, we can control networks actually.
Yeah. Okay.
Yeah. All right. So here, networks. OSPF is recommended for a larger network, enterprises net, corporate network, because it support for unlimited hop count and more advantages. Like in enterprise network, how one router can identify another router, how R1 will identify R2, how R2 will identify R1. So each router will identify another router using a ID called router ID. So router ID is to identify a router in OSPF domain. Then what will be the router ID for R1 router? Then what will be the router ID for R2 router? Host names cannot be a router ID. R1, R2. This is just only for our understanding purpose actually. Means user understanding, like engineers understanding. So and so router is R1, so and so router is R2. But not for devices. Then how R1 can understand R2? How R1 can identify R2? So each router will identify using an ID called what? Router ID. So simply can say a router ID is used to identify a router in OSPF domain. Then what will be the router ID of R1 is? In R1, total how many interfaces are there? In R1,
3.
E0, S00, S01,
S0.
three interfaces. In three interfaces, now we just configured OSPF, then OSPF automatically will choose route right actually. That we no need to be defined actually. OSPF algorithm itself, it will choose route ID. What is route ID? Here 10.0.0.1 IP address, 16.1.1 IP address, 17.1.1 IP address. So which is the highest IP address, that will be the route ID actually. Have three interfaces. In three interfaces, what is the highest IP address? Highest number?
17.
17.1.1.1. Then OSPF will decide 17.1.1.1 is a R1 router ID. If you have a 10 interfaces, out of 10 interfaces, highest IP address will be the router ID actually. So R1 router ID is 17.1.1.1. Similarly, then what will be the router ID of R2?
192.
192. 192.168.1.1 is the router ID actually. Now R1 will send hello packet to R2. Hello R2. R2 will send hello packet to R1. Hello R1. So once hellos are exchanged, then R1, R2 will establish a neighbor relation, right? Then R2 will build a table called neighbor table. So who is neighbor for R2? He's a neighbor for R2.
R1.
R1 is for user understanding, how R2 can understand, routers can understand.
17.1.1.
Yeah, so R2 neighbor is 17.1.1.1. So these tables we can check neighbor table. You can use command show IP OSP of neighbor, then you can get a list of the neighbors, active neighbors. 17.1.1.1 is a R2 neighbor. Similarly, R1 also will build a table and updating action. So he's a neighbor for R1.
192.168.
192.168.1.1 via S0/0. Here via S0/1. So these tables we call what? OSP of neighbor tables. It's clear, guys, everyone? Highest IP address will be the router ID actually.
So are these parameters cannot be changed, or like can we define the router ID?
Yeah, can be changed, yes. Let me complete this router ID concept. You can understand a little better actually. Tell me R1 routing table. Directly connect networks. 10.0.0, right? Next, 16.0.0.0, 17.0.0.0. 10.0.0 is connected to E0. 16.0.0 is connected to S0/0. 17 is connected to S0/1. Agree?
Yes.
So how many networks in R1 routing table?
Total 3 networks.
Why 3 networks? Why only 3 networks? Because 3 directly connected networks, then we have 3 networks only, correct? Agree? There are
Yes.
3 interfaces in R1. Serial 01, 00, E0. So each interface, each IP address, we got it 3 networks in routing table. But my requirement is I need one more network as a directly connected in R1 routing table. How I can get it? See, currently there are 3 interfaces in R1 routing table, right? And 3 networks are there. But what I need is I need one more network as directly connected. And how I can get it?
We'll configure one more serial interface.
Just insert like one more serial interface. Agree?
Yes.
Yeah. So add one more serial port. One more serial interface I have added. Say serial 0/2. IP address assigned 18.1.1.1. Now I can get one more update in routing table, right? Is that 18.0.0.0 is all are directly connected to serial 0/2. So now in R1, total how many interfaces are there? 4 interfaces.
4 interfaces.
Then how many networks in routing table?
Same 4 networks.
4 networks. 4 interfaces, 4 networks. But actually my requirement is I need 100 networks in routing table as directly connected. And tell me now how we can get 100 networks. Same logic, don't think much. I need 100 networks, directly connect networks in routing table. How we can get it?
96 interfaces.
We need to add more, another 96 interfaces to router. Agree?
Yes.
But before that, you can ask me a cross question. Okay, Balu, you're telling is good, but why do you need 100 networks in one router? Valid question or not? What is the purpose? Is I have one purpose actually. My purpose is my routing table having only 4 networks and I run OSPF protocol. How OSPF protocol will behavior? Like OSPF will feel any burden on router or it will run smoothly with algorithm because the routing table has only 4 networks. If you have only 4 networks, then OSPF will run very smoothly. There is no impact on the performance wise. Agree? Like what if I have a 40 networks in my routing table? Even if I have the 40 networks also, no impact on the performance wise actually. No impact on the CPU utilization, not much CPU utilization. No, everything is good up and running. But once my routing table is becoming a larger, there are 400 networks in my routing table. Earlier 4 networks are there. In the 4 networks performance, now 400 networks performance will be the same?
No.
No. So I want to test OSPF protocol. Like when it feels like more CPU utilization or performance wise down, like maximum how many networks it can be managed. Like once our network routing table is becoming a too big, like what changes will happen in the router? So router completely is going to be performance wise down or communication delay or bandwidth consume more because my routing is becoming a larger now. 400 networks, 500 networks, 300 networks. Then I want to understand the OSPF protocol behavior. If we only maintain 4 networks, then how we can understand the OSPF protocol behavior? In real network, suddenly, so some very more networks are added, and suddenly hundreds of networks are added to routing table. Then if you don't know how OSPF works, it will be impact on your performance. If you know already, oh, OSPF works with 100 networks or 200 networks or 300 networks. Otherwise, if more than routing table is too big, then performance will be down. We need to control the traffic. Then you can write the policies and you can control it actually. So we need to understand the OSPF protocol behavior. So that is the reason. I mean, I want to test that protocol. It's the reason I need more networks. If I have hundreds of networks and run OSPF and test it and monitor the screening it, monitor how traffic is moving, any impact or no impact, 100 networks, no impact, and add another 100 networks. Again, you test it. Again, you monitor it, how it works, performance wise, CPU utilization wise. Even 200 networks also performance is good, no impact, and add another 100 networks, 300 networks. Now we can experience, oh, there is a CPU utilization becoming 50%, and there is a communication delay, update delay, so that it can be test action. All of you following me?
Yes.
So finally, why I need 100 networks, hundreds of networks in routing table?
To test.
To test protocol behavior. Then how we can get hundreds of networks in routing table? Now tell me answer. Add another 96 interfaces. So which category router can support for hundreds of interfaces? Can branch router support for hundreds of interfaces? or ISP category router might be required? What category router required?
ISP.
Category.
What is the cost? What is the price of ISP routers?
Crores.
Crores. So crores of rupees router we need to purchase for what purpose ultimately?
Testing.
Test router's performance.
Not router performance, OSP performance.
Oh yes, yeah.
Yeah. So is it making sense to purchase a crores of rupees router for testing purpose?
No.
No. Once your testing is done, then we don't use now. Not required really that. But what is our ultimate target? We need a more networks on routing table. That is the target, right? So instead of purchasing and adding physical interfaces inside the router, we can create virtual interfaces. And each virtual interface, we can assign each IP address. So we can make our routing table is too big by creating a virtual interfaces. Our main target is what? We need hundreds of networks in routing table. Agree? So instead of adding physical interfaces and assigning IP address, we can create virtual interface. We call it as loopback interfaces. I'll show you how to create the loopback interfaces. By default, there is no loopback interfaces, but we can easily create. Once your testing is done, then we can easily delete. Show IP route. How many networks are there in my routing table right now? Only 3 networks. But now I need a more networks should be in routing table. Now instead of adding physical interfaces, I'm not adding any physical interface. I'm just creating virtual interfaces like loopbacks interface, loopback 1, IP space address 18.1.1.1, 255.0.0, done. Exit. Even no shutdown command is not required here because it's a virtual interface. You just create, it'll be active always. See loopback 2, enter. It's up. 19.1.1.1, exit. Interface loopback 3. Like this, we can create a number of loopbacks. Like as much how many you require. You want to make it hundreds of networks? Yes, we can make it actually by creating these loopbacks. Show IP route. I can see how many networks in routing table. 6 networks. Loopback 1, 2, 3, 4, 5, like millions of loopbacks we can create actually. Thousands of loopbacks. Now, once you updated 200, 300 loopbacks and your routing table is very large, right? Too big. Now run OSPF protocol and test it, how it behaves. Once your testing is done, then we can remove it easily. No interface loopback 3, no interface loopback 2, no interface loopback 1. Show IP route, we got default physical interfaces. Okay, to create interface loopback 1 or 2 or 3. To remove, we just add no interface loopback 3. Okay, I have created for testing purpose 2 loopbacks in my router R1, L1 loopback 1, L2 loopback 2. Loopback 1 IP address is 5.1.1.1. Loopback 2 IP address is 4.1.1.1. I created actually. So total how many interface in R1? Total how many interfaces are there in R1 now? 3 physical interfaces. to loopback interface. Total how many interfaces? 5 interfaces. Out of 5 interfaces, then what will be the router ID for R1?
The biggest.
17.1.1.
17.1.1.1 is not a router ID right now because of loopbacks. Once you create a loopbacks, then priority will go for loopback only. If loopbacks are not created, then OSPF will use highest physical interface IP address as a router ID. But once you create a loopbacks, then OSPF will give priority for loopback only. Why? Physical interfaces have a down state. They might have a down actually. See, serial 0/0, other end is 0/1. Serial interface 0/0 is okay. There is no problem in 0/0. There is a problem in R2 0/1. It is down. It is failed. There is some problem. It is failed actually. Now, if we check the status of R1 serial 0/0, what will show the status? R1 serial 0/0 status is up or it will show the down?
Down.
Down. But problem is where? Problem is in R1 serial port? No. Problem is where? R2 serial port now. So that is what serial physical interfaces have a down state. But loopbacks will never down actually until router down, complete router down. So once you create a loopbacks is always active. So that is the reason OSP will give priority for loopback. Again here two loopbacks, loopback 1, loopback 2. Now highest IP address. What is the highest IP address in loopbacks? 41115111. R1 router ID is now 5.1.1.1 is a router ID. R1 will inform to R2. Hello R2, I am 5.1.1.1. Oh, via serial 0/0, it's already 17.1.1 is my neighbor. In same interface, there is one 5.1.1 means there is one new router might be added. It is changing neighbor table as 5.1.1 and updating to neighbor table. I mean, updating to neighbors. Means to update the neighbors, it has to run algorithm. Correct? Neighbor to neighbor, neighbor to neighbor. The point is, why we created 44115111? For what purpose?
Purpose.
Testing the OSPF performance.
Testing purpose. Once your testing is done, what we can do? Remove it.
Removed.
I have removed loopbacks. If you remove the loopbacks, then again, what will be the router ID?
17.1.1.
Updating to R2. R2, I am 17 dot. Oh, it is via 0/1. It is 5.1.1, but you're telling is now 17.1. There is a new change happened. So it is running algorithm and updating to neighbors. Serial 0/1 is failed. There is some problem. 0/1 is down. Then what will the router ID? 16.1.1.1 is the router ID. Updating to router 2. Router 2 is updating 16 and running algorithm and updating to neighbors. Consuming bandwidth problem, right? So this router ID is something manually also we can be configured. We can define a router ID. Currently, OSPF is deciding automatically from physical interfaces or from loopback interfaces. But admin can define using this command a router ID. Let's say I have configured a router ID as 2.2.2.2 something. That's it. Now protocol will not involve to choose a router ID because admin is decided, admin is configured. Now R1 will update to R2. R2 I am 2.2.2. Router ID is 2.2.2. So once your router ID configured manually, now you create a loopbacks. Even the highest loopback IP also. No router ID changes. Router ID will not change. If loopbacks are removed, router ID will not change. Physical interface down, router ID will not change. It is fixed. We defined manually. We defined 2.2.2. Created loopbacks or removed loopbacks or interface are down, interface are up. Router ID is fixed action. So there are three priorities. First priority for manual router ID command. If router ID is not manually configured, then OSP will choose from highest loopback. If loopbacks are not configured, then OSP will use from highest physical IP address. Okay. So this is all about router ID. Router ID is used to identify the router in OSPF. First preference is given to router ID command. If router ID command is not configured, then second preference will go to highest loopback interface is configured on router. If loopbacks are not configured, highest physical IP address. Try to find out and tell me router ID on this diagram.
192.168.
168.
Yes. What if I configured loopbacks then?
UL.0.0.1.
If manually I configure router ID command.
2.2.2.2.
Yeah. No doubts. Okay. Excuse me. Let me show you this configuration part, OSPF configuration. Can read this. Router OSPF process ID. So we need to start configuring OSPF with any number. That number range also given 1 to 65,535. You can use any number. It's just a ID to start the process. You can use any number, and the number also, if it is the same number for all routers, no problem. If it's a different number also, no problem. Doesn't matter actually. You can use any number. Next, router ID you want to define manually, you can use this command. Router ID, your IP address. Network ID, directly connect network ID. Network ID with wildcard mask and area ID. There are two new terminologies. Let me explain about wildcard mask. Wildcard mask.
After this class, can you send this, the one which you are displaying?
Yes.
Thank you.
Wildcard mask is global subnet mask minus subnet mask is wildcard mask. Global subnet mask 255.255.0 minus subnet mask. It's a class A subnet mask 255.0.0.0. Okay. So global subnet mask minus subnet mask is wildcard mask. .255 minus 255. Is the value?
0.
0
255, 255, 0.
255 dot 255 dot 255 is a wildcard mask for class A networks. So I used class A subnet mask, right? Class A. Then what will be the wildcard mask of class B networks? For class B networks.
0.0
0, 0,
255 255
0 dot 0 dot
255, 255.
255 255. Class C networks.
0.0.0.255.
0.0.0.255.
Yes. 0 dot 0.0.255. So this wildcard mask we need to use for OSPF configuration actually. Okay.
Any specific reason?
Yeah, algorithm is designed like that.
Okay.
Next point is area. Area ID, like we have part 2, OSPF part 2. Today we just introduction, some OSPF characteristics are done with router ID concept. Still we have some more advanced topics are there in OSPF. Areas concept will continue in tomorrow actually. But default area ID is 0. Remember, area ID is 0.
Okay.
I'll show you the configuration part in R1. Show IP route. For all dynamic routing protocol, same method. You just open your routing table, you can see your directly connected networks. What are the networks are listed in routing table? That networks we need to configure in RIP or OSPF or EIGRP or BGP. Only directly connected networks. Config mode, config terminal, router OSPF, process ID. That number can be any number. My example 123. Enter. Network ID 172.16.0.0. Network ID wildcard mask. It's a class B network 0.0.0.255.255. Default area ID is 0. Done. Second network 172.18. Next network 192.168.1.0. Wildcard mask will be 0.0.0.255. Default area ID is 0. Done. This is R1 OSPF configuration. Tell me R2 OSPF configuration part. You can use same ID, same process ID or different also, no problem. Commonly I'm using 123. Network 10.0.0.0. Wildcard mask 0.255.255.255. Area ID 0. Next. Network 172.16.0.0. 0.0.255.255. Area 0. See, we got one log message. One neighbor is up, right? Yeah. Up. Network 172.17.0.0. 0.0.255.255. Area 0. Excellent. NBR means neighbor. Guys, tell me for router 3 configuration, please. Anyone? Yeah.
Config T.
Okay.
Router ID 123.
Okay. Network
172.17.
172.17.0.0.
0.0.255.255.
0.0.255.255.
Area 0.
Area 0.
Enter.
Yes. I'll get 1.
Network 172.18.0.0.
So 172.18.
0.0.25 area 0.
Yeah.
Network 192.168. One more network we have to add.
One more network. Network 192.168.2.0.
168.
Okay.
0.0.0.25.
255. Area
0.
We are 0.
done. Now if we check routing table, show IP route, you can see OSPF networks. Oh. So basically, what are the parameters need to be checked in routing table? The first thing is this 10 dot network. How 10 dot network got into my routing table? This 10 dot network, is it directly connected to my router 1?
No.
10 dot network is it is statically updated to my router 1?
No. Through
Like how
OSPF
10
it is.
dot network is updated? So through which protocol? So that is the main point actually. So first point, always to check about what? Code. By seeing this code, we can get to know, oh, so and so 10 dot network is updated with OSPF or directly connected or static or RIP, like how it is updated, how it got introduced in my routing table with OSPF protocol. Next, network. What network exactly it is? It is 10 dot network and by mask and which subnet it is. You can see the closed brass. Always there are two values. One is administrative distance of the protocol, and second one is metric of that protocol actually. So which protocol it is? It is OSPF. OSPF AD value is 110. What is metric of OSPF? Cost. So to reach 10 dot network, cost is 65. I'll explain that about later. I mean next session about cost clearly. But remember always this first value is AD value, second value is what? Metric actually. AD administrative distance, metric. And via next neighbor IP. Next we call hop IP. Next hop IP. Exit interface type where your traffic exiting. So total how many parameters need to be checked? Protocol code, network, which subnet it is, AD value, metric, next hop IP, exit interface. Okay. So you can see OSPF is updated. Oh. What else? So today we have completed with disadvantages of RIP protocol, link state protocol introduction, OSPF characteristics, OSPF router ID, wildcard mask, and OSPF configuration part. Tomorrow we'll continue with OSPF neighbor states, OSPF hello packet mechanism, like what is inside the hello packet, and cost calculations, areas concept, packet types, router types. So there are some advanced level OSPF. We'll continue tomorrow actually. So please practice on OSPF, the basic OSPF configuration. Thank you.